We're told that g of x equals the integral from a to x of f of t dt, with the graph of f shown here. Not g, but f, and a as a constant, any constant. We're trying to find the x values that refer to these conditions for the function of g. And so, we want to remember this relationship. If we're told that g of x equals the integral from any constant to x of f of t dt, by the fundamental theorem of calculus, if we found the derivative of both sides, we would find that g prime of x equals f of x. And this is incredibly important, because the first thing is asking us, where is there a relative maximum on g of x? Well, what do? We know that this g has a maximum when g prime equals 0, and when g prime changes from positive to negative. But the thing is, we don't have a graph of g, but we have a graph of f, and we're already told that g prime is the same thing as f. We know that to be true, and so we have to look at where that's happening. First off, where is g prime, or where is f? 0. I see that happens at 2 locations. But I also need to find when does it change from positive to negative. Well, at x equals 2, it goes from negative to positive, so that's not what we want. Instead, at x equals 6, I see that our value changes from positive to negative, and that's what we want. And so our answer here would be that a relative minimum, so we would say g has a relative minimum, or relative maximum, at x equals 6, because g prime, or f, is 0, and changes from positive to negative at x equals 6. And that's how you would answer that fully. And now what about the second question, concave down? Well, when is something concave down? We know that's true when the second derivative is less than 0, when it's negative. But we don't have g here, but we do have f. And since we know that g prime of x equals f of x, if we find the derivative of both sides, we know that g double prime of x is f prime of x. So if we want to find when g double prime is less than 0, that's also saying when f prime is less than 0. When is the derivative of f negative? And so we want to find the regions where that happens. I see, and I'm going to highlight where this is happening, I see that it's negative here, it starts to go down, and then it stays negative all the way down this way. And so I could name that this g is concave down, on the interval, I'm going to use parentheses here, on the interval 4, 7, because g double prime, or f prime, is negative on that interval. How do we know that? We know that it's negative because if we drew a tangent line there, we get some negative slopes. G double prime is the same as f prime. It really is important that we know that relationship between g and f for these types of questions.